So I found a website. I put two, actually. There's two of them that are on the link to the module under 10.1 that does a 3D plot. So like you can actually move this and you can kind of see what it would look like. There's this one, and then the other one is actually in color. But let's just say, so what's that first point? What is it again?
2, -5, and 6.
So 2 moves it. So I'm going to turn this so that the x is forward. Oh, I switched it all the way around. So here our x is forward, right? So this kind of matches, yeah, what it would look like on your It's a little glitchy from within here. Trying to get the x and the y to straighten out. Okay, so the x is kind of like, if you look at the one that's on your warm-up, it's kind of like the same thing. The x is moving forward and back, the y is left to right, and the z would be up and down. I just zoomed in a little bit. But if the point is 2, so if the x is 2, it's moving forward 2, and then what is it? -5, so I'm going -5, that's moving it left 5. And then the last one is +6, right? So it's going up 6 places. So you could see if I actually flatten this out and I had a tick mark running on that vertical axis, that would be 6 up. But because we've tilted this forward, it's really hard to see the vertical distance. So as long as you can give me an roundabout of where that should be, you're fine. Okay, it doesn't have to be exact. Obviously, you should be moving in the right direction. That thing should not be below the line. Then I would know that you went the wrong Z. Okay, but it can kind of give you an idea. So on here, it would go +2 would move it forward 2, left 5, 1, 2, 3, 4, 5, up 6, 1, 2, 3, 4, 5, 6, and we're maybe around there. All right, and then B is 1, 0, 2, so I'm moving forward 1, I'm not moving left or right at all, and I'm moving up 2, 1, 2. So B would be about there. Again, they don't have to be exact, but you want them to be in this vicinity of where it should be, okay? And there's two links on that. Like I said, there's 2 links on the module under 10.1 that have that like 3-dimension thing so you can see it. The other one has a little bit of color to it. It's a little bit different, but it kind of gives you that visual. So then the second part says find the distance and the midpoint. So we said the distance, we use the distance formula, right? So it would be the square root of x2 minus x1 squared plus y2 minus a -5 becomes +5 squared plus 2 minus 6 squared, and I get the square root of -1 squared plus 5 squared plus -4 squared, 1 plus 25 plus 16, which is the square root of 42, which breaks down to 2 and 21, 3 and 7, none of those repeat, so it would stay as the square root of 42. Questions on that one? So if you were to actually compare it to your distance here, okay, square root 42 is in between 36 and 49. That's like a 6.5, which is kind of similar to our vertical 6. So you can get an idea that you're on the right track. And then midpoint, we add the 2 x's and divide by 2. So 2 plus 1 divided by 2. Add the 2 y's, divide by 2. 5 plus 0 divided by 2. And then 6 plus 2 divided by 2. So I'd get 3 over 2, -5 over 2, and 8 over 2, which is 4. Questions on either of those? Well, all of those, the graphing, the distance, or the midpoint. God bless you. Okay, then this one says, find the standard equation of the sphere whose diameter has endpoints of 2, -4, -5, and -4, 8, 3, then identify the center and the radius. So if you think about your standard equation, which is x minus h squared plus y minus k squared plus z minus j squared equals the radius squared. That's the standard equation for a sphere. I need 2 kinds of information. One is the center of my sphere and one's the radius. Are you given either this time? No, I'm given the endpoints of the diameter. So if I had a sphere, right, something like this, it would be like endpoint to endpoint. Something like that. So how can I find the center?
You find the center from midpoint?
Good. Midpoint's going to give me the center. So 2 plus -4 over 2, -4 plus 8 over 2, and negative 5 plus 3 over 2. So negative 2 over 2, which is negative 1, positive 4 over 2, which is 4, negative 2 over 2, which is negative 1. That's the midpoint. That's the center. So that's going to get plugged into my H, to my K, and to my J. Negative 1. Oh, yeah. Did I say 4 and write 2? Or the other way around? Thank you. That should be 4 over 2, which is 2. And then the other piece of information I need is the radius. And there's more than one way to do this. What's one way? Plug in my H, K, J, and one of those points, right? Doesn't matter which one. That would be my X, Y, Z. Work it out, get the R. What's another way to do it? The distance from what to what? There's two ways you could do that, actually. I can do center to endpoint, right? That would give me the radius. I could do endpoint to endpoint.
Divided by 2.
And divide by 2. That gives me the radius. Okay, there's all those ways. So let's work through the first way, which is to plug it in. So this is going to be, I'm just going to pick this point first. So that X would be 2, Y would be negative 4, and Z would be negative 5. So 2, and then this is my H, my K, my J. 2 minus the negative 1 becomes plus 1 squared, plus negative 4 minus 2 squared, plus negative 5 minus the negative 1 becomes plus 1 squared, equals the radius squared. So I get 3 squared plus negative 6 squared plus negative 4 squared, 9 plus 36 plus 16, that's 45, plus 16, 61. So if it asks for the radius, which it is in this case, I actually have to take this and square root it. So the square root of 61 is my radius. And this, negative 1 to negative 1 is the center. If it asked, and then it said find the standard equation. So I have to do X, change the sign so it's plus 1 squared plus Y minus 2 squared plus Z minus a negative 1 becomes plus 1 squared equals the radius squared, which is just 61. So there's my equation, there's my radius, and there's my center. So when dealing with spheres, we had a couple of different types. One where I gave you the center and the radius. One where, in this case, where you've got the endpoints of the diameter. One where you had the equation not in standard form. You had to get it into standard form and then answer the question. I would just be prepared to be asked any of those types of questions for your test.
Can you go back to the first problem?
Okay, so under the module, under the chapter test little section, test and review, there's a note that says 9.5 to 10.1 review. This is it, if you want to open it up, so we have a little bit of a shell to build on. So 9.5 is your polar coordinates. This is graphing and then finding additional points. That's the first thing, and then converting from rectangular to polar and polar to rectangular. So those are the parts of 9.5. So if I gave it to you in R, theta format, which is polar format, and let's say I said 3 and I said 3 pi over 4. This little, it's grainy, but this is pretty much what it looks like on your test. So you're going to have to know the angles, which if you fill out your unit circle today and I give it back to you, you should be able to use that as long as you have it correct. But I'll just label a couple of them while we're at it. So remember, first quadrant is obviously the over 6, the over 4, over 3. Second quadrant is 1 less. Third quadrant is 1 more, so this would be 7 pi over 6, that's a pi, 5 pi over 4, and 4 pi over 3. And then the fourth quadrant is 1 less than double, or 5, 7, 11. So 5 pi over 3, 7 pi over 6, 11 pi over 6. 7 pi over 4, thank you. So if I have 3 and 3 pi over 4, then I'm going to positive 3 pi over 4, which is around here. I would go along this line, and if it's 3, I'm counting out 1, 2, 3 to the third ring, and that's my polar point. Oops. If instead of it being a positive 3, it was a negative 3, how does that change? Go the opposite, go away from 3 pi over 4. So if 3 pi over 4 is, again, this line, instead of moving in that direction, I would move across from it on the opposite ray, or the opposite angle, which is 7 pi over 4. That would be the negative one. So if they're both negative, let's say negative 3 and negative 3 pi over 4, the angles where I would move first, so negative 3 pi over 4, remember there's two ways to do the negative angles. Either find the positive one and then fold it in your mind. So positive 3 pi over 4 is here. Fold that in your mind and it overlaps with 5 pi over 4. Then you know that that's the negative angle. Or move clockwise from 0. So 3 pi over 4 is bigger than a half but less than a whole, right? So I'd be moving to that pi over 4. And then if it was a positive 3, it'd be here, but it's not. It's negative, which means I'm moving in the opposite direction, which would be there.
Oh, so you find 3 pi over 4 and you find...
So you find negative, well, to fold it, you mean? Or to...
So it was like a mirror? Like
Yep. Fold it in half along your x-axis, or your polar axis.
So you go the opposite.
Exactly.
Wait, can you zoom out?
Mm-hmm.
So when dealing with two negatives, you should find the radius.
Always do the angle first.
Okay.
Always do the angle first.
Okay.
Yeah. And then move opposite.
Okay.
Always do like the theta first.
Yep. And then move along that line.
Wait, why do theta first?
Because that tells you where you're putting your dot.
Oh, right.
And how far out you're putting your dot. Yeah.
Just being an idiot.
You're not being an idiot.
So you're just saying you just put those points there just to graph it?
Just different points, yeah.
Okay.
Yeah, so just know how to do all that. Know how to plot a positive angle, a negative angle, a positive radius, a negative radius. And then know how to find additional points, right? So we said one way to find additional points is to keep the r the same, but then add to the theta and subtract from the theta 2 pi, because that brings you at the same point all the way around the circle one more time. And then the other way to find it is to change the sign on the r and then add and subtract pi or odd multiples of pi. So I could add pi, I could add 3 pi, 5 pi, subtract pi, 3 pi, 5 pi, whatever it is. So if you're keeping the r the same, you're adding even multiples of pi. If you are changing the r, you're adding odd multiples of pi, and it will give you a range. Like if either give me the same point from 0 to 2 pi, you're looking for that range. Give me the same point from negative 2 pi to positive 2 pi, then you're using that range. Mikhail?
When do you find like the negative part of it? Like when you just find the negative range but on the opposite side?
That's if you need to find another point that's in between, let's say, so if let's say I wanted to find the same point of this, 3 and 3 pi over 4, within the range of 0 to 2 pi. Let's just say I want to do that, right? So if I add 2 pi onto 3 pi over 4, it's too big. If I subtract 2 pi from 3 pi over 4, it's too small. The only other way to find a point is to change that 3 to be a negative 3 and then add or subtract pi. So if I change the 3 to be a negative 3, now it's negative 3 pi over 4 plus pi, which would be 4 pi over 4, is 7 pi over 4, and that's still on my unit circle.
So you have to change the sign on the...
If you're adding and subtracting pi, if you're adding and subtracting 2 pi, you don't change the sign because you're finding a coterminal point, basically. You're saying, okay, if this is the point I want to find, I go all the way around the circle one more time, or I go all the way around the circle one less time, and it brings me to that exact point. But if it gave you a restriction, like it had to be between 0 and 2 pi, you can't use... Yeah, exactly. Does that make sense? So if you're changing r, you're adding and subtracting odd multiples of pi. So it could be you're adding pi, you're adding 3 pi, you're adding 5 pi, subtracting those if you needed multiple ones.
How
Okay.
does negative 3 and 3 pi over 4 correspond to 3 comma 3 pi?
They don't. No, those were additional examples.
Oh, okay.
So this is the same as that.
How do you know when to use those two?
It's going to ask you for additional representations. You're going to have to use whatever you can use to get the point. So it depends on the range and the point. Try 2 pi first, and then if 2 pi is too big or too small, then you know you have to go to the other one. Most likely you're going to have to do both.
Ms. Crusoe, could I ask you, how do you get negative 3 comma negative 3 pi over 4?
I just made that up. They were asking me what happens if the r is negative and the angle's negative. So these do not match this. They're not the same point. The ones that do match are this one and this one. The other ones were just examples. No, I could keep going.
So would we get like a coordinate point like those?
So you're going to get a graph and find additional points within this range.
Do they all have 3 additional points?
If it's within, I mean, it depends on the range, but I'm not going to give you one you can't find. If I ask for 3 additional points, you're going to be able to find 3 additional points.
On the review, I was trying to do 1, but I could only find 2 and not 3.
So if we get to the end and we have time, I'll go back over that. Okay, and then conversion. So we went 2 ways with conversion. We went from rectangular to polar, and we went from polar to rectangular. So if it's in rectangular, it's going to say x comma y equals, and it's going to give you a point, like let's just say 2, negative 2, something like that. So the equation for this, 1 I need r, and 1 I need theta. So I find r by using r squared equals x squared plus y squared. And I find theta by doing tangent of theta equals y over x. So those are formulas you need to know. So in this case, r squared would equal 2 squared plus negative 2 squared. 4 plus 4, which is 8. R squared would equal 8. So r would equal square root 8 or 2 root 2. And then tangent of theta would equal y over x, which is negative 2 over 2. We're saying the tangent of theta equals negative 1. So again, if you fill out your unit circle and you add the tangents on, for negative 1, how many answers is there on my unit circle? There's 2, right? Tangent's negative in the second quadrant at that over 4, and in the fourth quadrant at that over 4. So technically I have 2 choices here. I've got 3 pi over 4 and I've got positive 7 pi over 4. How do I pick which one? You got to think about where that point is. So if that point is positive 2, negative 2, what quadrant is that point in? Fourth quadrant, which means I'm picking 7 pi over 4. So you have to either plot it or visualize it. I don't care if you actually plot it, but you got to know where that point is in order to pick between the 2 tangents. There's always going to be 2 options for tangent, and the graph of it is what's going to tell you which one to pick.
Say that again. Like, how do you know which one? You look at like tangent negative 1.
So graph 2, negative 2. Where is that?
The first one.
Yep. So there's 2 places on my unit circle where tangent is negative 1. It's at this one and it's at this one. This is the one that's in the fourth quadrant, so that's the one I pick.
So you would just test like by graphing it as if it was on a normal plane? Okay.
Like I said, you don't even have to know exactly where it is. You just have to know if I'm moving forward and down, that's in the fourth quadrant, and picking that fourth quadrant angle. 1.
What exactly does R stand?
R is the radius, so that's the ring. That's how far out we're moving. Yep.
Okay.
So if I estimated square root 8, right, and I went to 7 pi over 4, and I went 8, which is a little bit less than 3, it should literally overlap with 2, negative 2, if I'm accurate on both.
So like the thing where it's like sine equals like y over r, is that?
So that's the next one. Yep, so that's polar to rectangular. So polar to rectangular, the 2 formulas, to get from polar to rectangular, I'm going from r theta, right, to xy. So I would do that x equals r cosine theta, because remember x is cosine, those should go together, and y equals r sine theta, because y is sine. So if I gave you, let's say I gave you negative 2 and pi over 3. X is going to be negative 2 cosine of pi over 3. Y is going to be negative 2 sine of pi over 3. And if you know your unit circle, you fill it out. You know pi over 3 has 1/2 root 3 over 2. So the cosine is 1/2, and the sine is root 3 over 2. So this is going to be negative 1, and this is negative root 3. So I would write it as xy equals negative 1, negative root 3. And again, if I had plotted negative 2 pi over 3, I know pi over 3 is here. Negative 2 says go in the opposite direction. It would be here. And then if I went to plot negative 1 and negative root 3, which we would approximate to negative 1/4, I would go back 1 and down about 1 and 1.4, which puts me at that same place. So you can check it visually to make sure that you're on the right track. I estimated negative root 3 to be 1.4. Oh, how did I graph the polar one or the rectangular one? So negative 1 moves back 1, and then negative 1.4 goes down 1.4. Just like you would plot it on a regular XY chart. It's just that that's a polar one, so you got to visualize what it would look like, yeah. That was all without a calculator. So you're also going to get 2 questions on your test that are with a calculator, okay? My advice is use your graphing calculator because it's easy. They're 1 buttons. But if you don't have it, you can use a scientific calculator. You just have to plug it in like the equations. So if I told you that xy was negative 7 and 2.5. So I could find the radius either one, except it might not be so fun doing like 2.5. If I gave you something like 0.675, you're not going to want to do x squared plus y squared with 0.675, right? If you have your scientific calculator, go for it, okay? But it's a little bit more work. But on a graphing calculator, remember in second angles, so if I go to the button that says second and I go to the button that says apps, there's an angles menu there. And then if I'm going from rectangular to polar, which is this, I would do rectangular to polar, and the first thing I'm going to do is R, because there's 2 of them, and I would type in negative 7 and 2.5, comma, 2.5, and the comma is above this 7 on your graphing calculator. You want to make sure that your graphing calculator is in both radians and polar in order to do this. The scientific's not the same way, but the graphing calculator is. So rectangular to polar R, negative 7, comma 2.5, gives me that the that the R value is going to be 7.4. I'm just going to round it to 1 decimal place, but pay attention to your test if it says 1 or 2. And then rectangular to polar theta, again, I'm going to type in negative 7, comma 2.5. And I get theta equals 2 point, this time I'm going to round, again, 1 decimal place to 8. So this point in polar format is 7.4, comma 2.8.
We need to make sure.
You need to be rectangular and polar. I mean, sorry, radian and polar. So both that and that.
When you do it again, you're doing. Oh, so once you find R, once you find it up.
Exactly. And then you'll repeat. Yeah.
So on the test, is it going to be written with like x, y is equal to this?
No, the directions say
It's going to say it written.
convert from rectangular to polar or polar to rectangular. Yep. And then if I want to go the other way, so if I give you that R theta, let's use the ones that's there, 7.4 and 2.8. Then I go back to the same menu, but this time I'm doing polar to rectangular X and then polar to rectangular Y. So polar to rectangular X and type in 7.4, comma 2.8. And I get negative 6.97, which is the same thing as negative 7 when rounded. And do it again. Polar to rectangular. Y. 7.4, comma 2.8. And I get 2.5.
Why did you multiply it by -7?
I didn't. That's the answer.
This is you going.
I just went the other way around so we could double check our answers, but they would probably be 2 different. They are, not probably. They are 2 different questions.
How many questions is the test?
There's actually, I have to look at that again. There's 2 of these. 11. Oh, look. Questions on that. So that's the only part of your test you're going to have a calculator. And again, I would strongly recommend a graphing calculator. If you don't, it's an entirely different process. You could do it, but you have to use these equations. So I'd have to do, if I'm going from polar to rectangular, I'd have to actually work this out. And on this one, I'd have to do tangent -1 of whatever y over x is. which is not going to be on your unit and circle. It will give you the right angle, but you want to make sure you're in radians for that too. Anybody not have access to a graphing calculator? Okay, good. All right, 9-6 is your limicons, rows, lemniscates, and circles. Amanda's favorite. So the first thing you're going to have to figure out is which of the 4 they are. You're going to get 2 of these 4, okay? You might get a limicon and a rose. The person next to you might get a limicon and a lemniscate, or a rose and a circle. You're going to get 2 of those 4 in any kind of combination. So the first thing you have to do is figure out what kind they are. A limicon is an R equals A plus or minus B cosine theta, or R equals A plus or minus B sine theta. So they will both be R to the first power, and then there will be something added to or subtracted from the trig function. It might be 1 plus and minus cosine of theta. That means both the A and the B are still 1, but that's still a limicon. Once you identify it's a limicon, you got to figure out which of the 4 types they are. So when we went over it, I said if you could take the inner loop, so if I start with the inner loop all the way to the left and eventually push that inner loop out, you get to the heart shape or the cardioid, then you would get to the dimpled, and then you would get to the convex. And the numbers underneath them, which is how you determine it, would go from left to right along your number line. So if I had, the first one is an inner loop. So if I start, that's a bad example. Like that, there's an inner loop, okay, it would be right through that X here, okay. This means your A over B is less than 1, or no, less than 0, which means it's negative. No, I'm an idiot, sorry, less than 1. I can't put less than 0, less than.
So would you say it's beneficial?
And then if I move further, so if I push out the loop, it becomes heart-shaped. Oh, so this is called inner loop. The heart shape is called a cardioid. And in that scenario, A over B is equal to 1. And then comes a dimpled, almost like a lima bean. And in this case, A over B is in between 1 and 2. And the last case is a convex, so it's got a flat side. And this is where it's greater than or equal to 2. So once you know it's a limicon, then you'd need to know which of these 4 it is. And these are cosine representations where that little loop or heart or all that stuff is happening along your x-axis or your polar axis. If it was sine, this would be flipped. There'd still be a loop, there'd still be a heart, but maybe it's vertical instead of it being horizontal, okay? So the loop is going to happen on the horizontal if it's cosine. But if it was sine, it would be vertical. You'd still have a loop, you'd still have the cardioid, you'd still have the dimple, you'd still have the convex. So what I was saying before is if you think about the loop being all the way on the left, if something was pushing that loop out, the next shape it would take on is the cardioid or the heart shape. The next shape it would take on is the dimpled one, and then the last shape would be convex. And if you're going in order from smallest number up to the largest, then that should make sense along your bottom line. A over B is less than 1, A over B is 1, A over B is in between 1 and 2, and A over B is greater than or equal to 2. So we don't take the sign on the B because that middle sign is plus or minus. So you want to ignore the sign on the B, but you want to take the sign that's on the A, okay? And then from there, which we'll get to in a second, we would talk about symmetry. Is it symmetric to the x or to the polar axis to the pi over 2 line? And then from there, you would plot your points and figure out. If you have no idea how to do these, you're going to spend a crap ton of time plotting points, and you're not going to be able to finish. So you want to make sure that you would know what the shape would be You would want to know what the symmetry is, and it will literally take you half the time to graph it. Amanda.
So once you find the symmetry, you figure out which one it is, then what?
So I would figure out which one it is, and then find the symmetry, and then based on that, you would figure out where you're plotting points. So if it's symmetric to the polar axis, then I would plot stuff from the top, and then I duplicate it underneath. If it's symmetric to the pi over 2, then I plot stuff to the right, and then I would duplicate it to the left.
So pi over 2 is your y-axis.
Yep, that's your 90-degree line, right?
Why would you do it on this side of the pi over 2?
It doesn't matter. You could do right or left. You would just flip it over. It's just that
any
usually
pi
you usually do first quadrant just because you know those points best.
Okay, and
But
then
you
if
could-
you're here,
You would do the top and then flip it over, or you could do the bottom and flip it over, but it doesn't matter.
but in reality, you can just do any side and flip.
Yeah.
How many points do you want?
I would say you want enough to get your curve. So I would say you want your axes, the 0, the pi over 2, the pi, and then maybe 1 from each quadrant until you get that shape. Unless it's a rose, the rose is a little bit easier. You don't have to do as many because you can just find the A. But for these, 5 points should get you the curve on the top or the right.
But once you have the shape, in reality, you have 5.
Then you just duplicate it, which means you really have 10 points. Well, not 10 because only 3 of them get duplicated, but. Okay, then comes the rows. So the rows is an R equals, and this time it has a number here. So whether it be sine or cosine, and then it will have a number in between. So you won't have anything added or subtracted. The r's going to be raised to the first power, but there will be a number in between the cosine and the theta and the sine and the theta. If that number is even, then you would double it to get the number of petals. And if it's odd, you don't. You leave it alone. You get the same number of petals. So if it said something like r equals 3 cosine 2 theta, this is going to be a rose. It's going to have 4 petals. And then the number out front, the A value, is how far out those petals go. So the radius of the largest point on that petal is going to be 3. So if I was to graph it, I would know that it's also symmetric to cosine, which means that it's symmetric to the polar axis. So it's going to be something like 1, 2, 3, 4, or it could be 1, 2, 3, 4, where both it's reflected over that polar axis or the x-axis. So I would take and plug in points like 0, pi over 2, pi, and 3 pi over 2, and see if from there I can get the A, and that's how far out those petals are going to go. So if I just plugged in 0 here, I'd get 3 cosine of 2 times 0, 3 cosine of 2 times 0 is 0, the cosine of 0 is 1, 3 times 1 is 3, and already I know 1, 2, 3, that's how far out it goes there. Because it reflects over the x-axis, I would know it would look like that. It's going to come back over this way, and my petals will go in all 4 directions. If it was cosine 3 theta, let's say, then it would be 3 petals. And again, if you can't figure out your pattern or your symmetry, you would just have to plot in extra points. The lemniscate is your infinity shape, and so these are your only r squared. So this would be r squared equals a squared sine 2 theta. R squared equals a squared cosine 2 theta. So again, they're the only ones that are squared, which means these are going to be symmetric to your pole. They can also be symmetric to your polar axis if they're cosine. But they will be symmetric to your pole because if you plug in a negative r, the r squared is going to make it go back positive. So these look something like, again, your infinity symbol, where it would be just symmetric to the pole or symmetric to the pole and to the polar axis where it's the cosine. And then the number on the front is the square of A, and that's how far out your petals go. So that if it was 9 sine 2 theta, the furthest point out would be the square root of 9, which is 3, and that's how far out your radius would go. So lemniscate, do the same thing, know that it's infinity shape, but plot some points, figure out where your curve goes. Okay, and then the last one is circles. So your circle does not have anything added or subtracted to it, and it simply just has the cosine of theta and the sine of theta. This time the thing on the front, the A, is your diameter. So the cosine would be symmetric to the polar axis, something like this. And the sine would be symmetric to the pi over 2 axis, something like this. And end to end here, the diameter is A. End to end here, the diameter is A. So I would do the same thing, figure out the symmetry, figure out that it's a cosine, and then plot some points to figure out where your circle goes. All right. The last thing is our test for symmetry. So our quick test for symmetry is if r is not squared. So if r is not squared, but I've got a sine of theta or a cosine of theta. So if there's sine, think sine is y, then there's symmetry to the theta equals pi over 2 line, which is your vertical axis. If it's r equals a cosine theta, then think cosine x coordinate, and x axis, and the x axis is your polar axis. So it would be symmetric over your x axis or your polar axis, and you can reflect down like a hamburger. And then the only other one is if it's symmetric to the pole, and in that case, you would replace r theta with negative r theta. So if you think about what would get rid of a negative on an r would be a squared. So your limnaskates are going to be symmetric to your pole. All right, hopefully that helps your graphs. There's an example on the next slide. There's some examples, obviously, from the original homework or the original notes and the warm-ups. Good luck. All right, so we're going to do an example. So immediately you should be able to tell me what kind this is. The parent of it anyways, which is what? A limison. Okay, and I know that because it's something plus or minus my function, and it's not squared, right? So I know this is a limison. So then the second question comes into what type of limison. So if this is my A and this is my B, I would do 3 over 2. And then it's either less than 0, equal to 1, in between 1 or 2, or bigger than 2. What's this? This is in between 1 and 2. So this is like, write it that way. In between 1 and 2, which if you could picture in your head as you're moving from left to right would be the third limison, which is what? Dimpled. Yep.
If that plus 2 was a minus 2, would that change it?
So the in-between side you don't keep because it is plus or minus. My original equation is plus or minus. The sign on the 3 is what you would keep. So if that was a negative 3 plus 2 cosine theta, now it's a negative 3 halves, which makes it a loop. So the sign on the on the A is what you would keep, not on the B.
So if the 2 doesn't matter.
Negative 2 doesn't matter, you keep it as 2. Yep, because your original equation is plus or minus, which it means like the sign doesn't count. All right, so now I would say what kind of symmetry does this have? To the polar axis, right? How do I know that? Cosine. Cosine without an r squared. Symmetric to the polar axis. Because if I find the cosine of an angle or I find the cosine of a negative angle, they're the same thing. It eliminates the angle, right? It eliminates the negative. That's why this is that case. So that tells me that whatever's going to happen on the top of this is going to happen on the bottom. So I'm just going to start plugging in some points. So I would do theta. And I would start at 0. Maybe do pi over 4. Maybe do pi over 2. 3 pi over 4. Pi. See what I get. So 3 plus 2 cosine 0. This is where your unit circle again is going to come in handy, but the better you know it, the quicker you can do these. So the cosine at 0 is what? 1. So this is 3 plus 2, which is 5. 3 plus 2 cosine pi over 4. 3 plus 2 times root 2 over 2. 3 plus root 2. And we approximate root 2 to be 1.2 because it's pretty close to 1, right? So let's say that's 4.2. And then I would plug in pi over 2. 3 plus 2 cosine pi over 2. What's the cosine of pi over 2? 0. So I get 3. 3 plus 2 cosine 3 pi over 4. So I know it's a root 2 over 2, but this time it's negative. So 3 minus root 2. which is 1.8. I feel like this is the same example we did at the beginning. Like my brain can only give you so many examples off the top of my head. 3 plus 2 cosine at pi. Cosine at pi is -1. 3 minus 2, which is 1. So then I graph. So at 0, it's 5. At pi over 4, it's 4.2. At pi over 2, it's 3. At 3 pi over 4, it's 1.8. At pi, it's 1. And then it comes back out because it duplicates on the other side. So 5 pi over 4 would be 1.8. Pi over 2 would be 3. Pi over 4, it'd be 4.2. And back to 2 pi would be back at 5. Yep. And then 10.1 is back to kind of where we were at the beginning of today. So you want to be able to graph a point. So if I gave you an x, y, z, could you graph it? Or if I gave you it in words, if I'm at the origin and I'm moving 3 places forward, 5 places left, 4 places down, could you convert that into points? Does that make sense? Yeah. I'm not going to give it to you with a graph point and ask you to find it. I think that's too hard to figure out your z. But both of the other ways, be prepared to do it. So graph it and then also decipher it from words. And then your distance formula, which hopefully we remember. We just reviewed it a little bit ago. x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Midpoint, x1 plus x2 over 2, y1 plus y2 over 2, z1 plus z2 over 2. The sphere we also did on the warm-up. So x minus h squared plus y minus k squared plus z minus j squared equals r squared. So these types of problems, we did a couple of different ways. The ones in the notes where you got the center and the radius, you had to give me the equation. In the warm-up where you had the endpoints of the diameter and you had to give me the equation. And then also in the notes and on the homework was if it's not in standard form, getting it into standard form, doing complete the square. God bless you. And again, giving me the center and the radius. Make sure you know how to do all of those. Questions? Do you want me to do some of the graphs?